Thank you, Natalie. Thank you for organizing the symposium. Um, let's just jump right in. Let's see. Okay, so what I'm showing you right now is a figure that it's an exemplar of one baby's sleep data over their first year of life, but it's representative of the typical trajectory of sleep in infancy. You can see that it shows the number of night wakings over the first year, and in general, those night wakings are decreasing as babies get older. But what you can also tell is that this developmental trajectory of sleep is characterized by punctuated periods of intermittent sleep disruption. So in general, night waking is decreasing, but then every so often you see this spike in night wakings. So even as sleep is becoming more consolidated in general, here we go. Infant sleep is becoming more fragmented around the time that they acquire new motor milestones. So over the transition from pre-crawling to crawling, for example, crawlers have higher rates of sleep-related difficulties than age-matched pre-crawlers. And similarly, the younger that infants are when they learn to crawl or to pull themselves up to a stand, the more likely they are to experience disrupted sleep. Now, deviations from the average of night sleep duration or the average number of night wakings were found to be temporally linked to the onset of sitting, crawling, pulling to stand, and walking in some of my previous work. But we also found that these links were not always temporally consistent. So meaning that the disruptions were just as likely to precede as to follow a motor skill onset. And we also didn't find any distinctions between the onsets of stable skills like sitting versus mobile skills like crawling or walking. And so that we thought suggested that infants' night wakings were probably not compensating for an earlier separation during the day. So that when maybe when babies start to crawl, they're newly independent and they're away from their parent and out exploring during the day. Maybe they're seeking contact comfort at night, but we didn't find any of those differences. Well, despite these earlier findings, we still have many questions about the underlying relationship between sleep fragmentation and motor milestone acquisition. So my research group and I have two main questions that I'll talk about today. Our first research question is about what drives night wakings that are associated with the onset of new motor milestones in infancy. Now, it may be that infant sleep is disrupted upon motor skill onset because infants are waking themselves up while they're consolidating these new skills, either through increased bodily activity or increased neuronal activity in their sleep. We know that active sleep is associated with neural reorganization in children younger than 2.5 years old, and that the onset of each new skill might increase the necessity of active sleep to cope with this systematic developmental change. Also, because infants are more easily roused from active sleep than from quiet sleep, could be that an increase in active sleep as a result from consolidating information might then contribute to more fragmented sleep through the night. Our second research question is about the nature of the activity that underlies the relation between motor milestone onset and infant sleep patterns. So to do this, I'm going to talk about some work coming out of my lab in collaboration with my current doctoral student, Erin DeMasi, and former doctoral student, Melissa Berger. And in this work, we directly document infants' behaviors in the crib using Nanit, Auto-Videosomnography, or video from the crib. And we did this longitudinally. We tracked infants' motor skill onsets and their changes to sleep over the course of their first year. So today I'm going to talk about just a subsample of the data from about 21 infants. And our aim was to prospectively capture the onset of key motor skills. Infants' age when they started participating in the study ranged from less than a month old to 11 months, and all of the babies participated until they started walking. And for the purposes of this talk, I'm just going to report the data around the transitions to crawling and transition to walking, even though we asked parents to report a whole long list of motor skills. So we use two data collection measures. The first is a daily checklist diary. Parents use this every day to keep track of infants' skills. The parents really put in a heroic effort in participating in this study. The diary listed over 50 gross motor skills, which were grouped by postural system and expected order of appearance. So prone and sitting skills were listed first, followed by crawling skills, followed by upright skills, and so on. And the diary included gradations of the same skill because we really wanted to capture changes in infants' proficiency. So we would have separately crawling less than 10 feet and crawling greater than 10 feet, or subcategories of the same skill. So belly crawling versus hands and knees crawling. And every day for every item, the parents indicated yes or no whether the babies had performed that skill. And we gave the parents detailed manuals that provided definitions for every skill and every behavior to ensure consistency in parents' understanding of the criteria. And then our second measurement tool was the Nanit video baby monitoring system, in which we collected and analyzed not just the sleep metrics, but also the videos of babies in the crib. And if families who agreed to participate were not already Nanit users, we lent them cameras that were attached to our lab Nanit account. As you've heard already from many speakers about how Nanit works, I'm not going to go into those details, but I will talk about how we the two ways that we used the videos from the parents. So the first result that I'll describe is a general result about babies' activity in the crib. So Nanit generates heat maps every night showing where babies spend time in the crib. So this heat map is one example showing unspecified, just general movement around the crib over the course of the night, with the red area showing the area of the crib that has the most activity. So let me show you what that looks like over time. So this is just an exemplar of one baby heat map over the acquisition of two motor skills over about 16 days. But using the heat maps are really only descriptive. They're not really explaining this relationship that we're interested in. So we dug deeper into this rich data set. I may orient you to the graph that I'm showing you now. This is showing activity in the crib, similar to what was in the heat map, but it's showing it over the transition. Here we have infants' first crawling steps and infants' first walking steps. And on the y-axis, we have the maximum number of minutes that infants spent in one location over the night. So the red area in the heat map. And this is showing a significant effect of night on most activities spent in one place, with a slight decrease over the week surrounding crawling onset, then an increase leading up to walking onset, and then another decrease after walking onset. And we also examined this pattern with wake episodes. This is essentially the same as the previous figure, but I added walking more than 10 feet to show the onset of the skill and then mastery of the skill. Crawling on hands and knees greater than 10 feet had the highest number of wake episodes surrounding skill onset. So this compared to periods of before the onset of crawling to the after the onset of crawling. And then wake episodes increased and then decreased over the transition as infants learned to walk from just their first steps over to mastery of walking. So the heat map data generally shows a description of movement in the crib, but our second question was really about the nature of that activity. What were babies actually doing in the crib? What did they look like? And were they related to the specific skill? So this is showing a sample video of the kind of video that we collected from families. For a subset of the larger sample, we had access to this Nanit video, and we requested nights of video around the onsets of the skills that parents were reporting in the diary. And we used data coding software to code frame by frame, hundreds of hours of video from the nights just prior to and of, and then just after motor milestone onsets. So for this case, I'll talk about crawling and walking again. The research assistants who worked on this, again, just like the parents, heroic efforts in coding these videos. First, they identified the wake episodes from the video, then they categorized the whole body movements that the infants were engaged in. So I'm gonna next report on limb movements and then hands and knees postures, just as a place to start, because these movement patterns seem important and relevant for the acquisition of crawling and walking. So here's some preliminary data that's showing movement during wake episodes in the crib around the onset of the skill. So again, this is the night before the onset of crawling, the night of, the night after, and again for walking, night before walking, the night of, the night after walking. And using milestones, so crawling and walking, and then also night, so before, of, and after as predictors on the proportion of time that babies spent moving their limbs, that's in purple, and on hands and knees postures, it's in yellow, during these wake episodes in the middle of the night. And we did find an interaction between milestone and night, so that the time that babies spent moving their limbs decreased the night after they learned to crawl and decreased the night after they learned to walk. And then the proportion of time that babies spent on hands and knees was higher on the night that they learned to crawl than on other nights that we measured. So to summarize, first, we examined the relationship between infants' general activity during sleep and their motor skill onset. And our preliminary findings suggest that the effort that it took, effort that was required to perform a new skill, this gearing up in preparation, and then the execution of this new skill might explain these changes in activity levels during sleep that are associated with the first performance of the skill. So prior to consistent performance, we think that changes in activity levels during sleep upon motor skill acquisition may stem from cortical activity that's associated with learning, or perhaps general arousal that is associated with the consolidation of new information that is learned when babies are awake, but that is then reactivated during their sleep. So next, we looked at the relationship between specific postures during sleep and motor skill onset. And these results suggest that increased posture-specific behaviors during wake episodes may reflect infants trying out these new skills during their sleep. And so this may explain previous findings from other researchers that infants who've begun to crawl are more physically active during sleep than non-crawlers. And then our third finding raises the possibility that sleep movements might differ depending on whether babies are preparing to learn a new skill or whether they're in the middle of mastering a new skill. Skill onset marks a period of changing neural patterns where the activation in the motor cortex starts out diffuse at skill onset, but then becomes more refined as infants gain more experience with that skill, as more experience is acquired. And so maybe perhaps the sleep disruptions are reflecting a system-wide change as this pattern is repeated over and over again with the acquisition of each new skill. As we keep working on this, as we continue collecting and coding this data, one of our main goals is to zoom out beyond just those few nights around skill onset. We're really interested in documenting sleep activity as a function of skill expertise. And so thank you for your attention. Of course, thank you to all the students in the Child Development Lab who worked so hard on all the coding, especially Erin and Melissa, and always thanks to Natalie for being such a strong supporter of this work.